and I'm going to start with a question from 1.4. This is on page 40, question number 6. So if you're following along, you can grab your textbook at this point in time. Page 40, question number 6, and let's look at this together briefly. So we have Claire wants a down payment of $17,500 to buy a house in 10 years when she turns 30. Her bank offers her an investment with 5.6% interest, compounded semi-annually. What present value is needed to invest right now? So I'm going to do this and the next problem both with the TVM solver. So I'm just going to set up the chart the same way it would be in your TI calculator. So I think it goes present value, payment, future value, payment per year, compounding period per year. And you're going to put a value into each one of these, and then you're going to highlight the one that you're looking for and press alpha solve. If you are looking for a review on how to get to here, you can open up my 1.4 video, but under the calculator, you want apps, and then I believe it's finance, and then the first one on the list is TVM solver, and that will bring you into this menu that we have on the screen right now. Looking at my stream, I see that part of the bottom is cut off. Let me see if I can fix that quickly. Okay, not perfect, but I think this will do. I just want to verify that it showed up on my stream, and it didn't. There we go. All right, things should be okay now. Okay, from here, question number 6. So Claire wants a down payment of $17,500 to buy a house in 10 years. So the amount of money that Claire will need in 10 years is $17,500. So that is the future value. What we're looking for is the present value that needs to be invested right now. So this is what we're trying to find out, the present value. Now there's no repeated payments. So PMT is going to be 0. This PMT thing only shows up in the 1.5 exercises and further. It says the bank offers an interest rate with 5.6% interest. So for I, we're going to use 5.6. Compounded semi-annually so C over Y is 2. And we're going to set P over Y to the same thing. So this is 2 because it's compounded semi-annually. And basically, we make these the same for problems where there are no payments. If there are regular payments, then these values can differ. So you can look at the 1.5 video for an example of that. Now, she needs this in 10 years, I believe. So this will be 10 times 2, and you can just put 10 times 2 in your calculator. It will show you the value of 20 when you do that. The 10 is because of the number of years, and the 2, well, that is whatever value is in P over Y. All right, so what we want to do is find PMT. So you're going to put these values into your calculator, and then you're going to press the green alpha key, followed by enter, and that will choose the solve option on your calculator. Okay, I have my calculator opened in the background here. I was trying to get it to show up on my screen, on my stream, but my screen was a little too cluttered. So I'm going to work this problem mode in the background. If you have your TI, or if you want to use a TI on the internet, you can work it out similarly to me right now. So my value of N is 20. My value of I is 5.6. My PMT is 0. My FV is 17,500. P over Y and C over Y are both 2. So, almost selected the wrong thing. So I ended up with the value of negative 10073.39 when rounded. So what does that tell us? Well, the question was asking what present value will need to be invested right now. So she needs to invest, according to these constraints, $10,073.39. And if she does that, then in 10 years' time, under these restrictions, the value will accrue to $17,500. Okay, so that's an example from 1.4. This one could have also been solved with the formula. The problems from 1.5 are not really feasible to solve with the formula, however, and this is where kind of the power of the TVM solver really kind of comes into play. So I'm going to move on and do one or two problems from 1.5, and then I'll see if anybody is around and has questions, and if not, I'll just end it there. So let's go on to the next video. So looking at 1.5, these problems begin on page 55. And I think I will choose excuse me. I think I'll choose number 5. Let me just read it through quickly here. Okay, so it seems like a suitable problem. So I'm going to put my grid in again. This is the same thing that you would see on the TVM solver. When I ask for work from this unit to show your work, I would consider showing me this grid with the values that you put it in and the value that you determine to be sufficient for showing me your work for any of these questions. So you should make a grid similar to the one that I'm making here. All right, so number 5. So we have Fraser, 16 years old, wants to buy a car when he is 21. So that's going to be 5 years. So 5 times something. He deposits $600 every 3 months. So P over Y is how often the payments are made every year. So if it's made every 3 months, how many times is that going to happen in a 1-year period? So 3, 6, 9, 12. So P over Y is going to be 4. And this because, let's save green for something else. This is because there are payments every 3 months. Therefore, there are 4 per year. All right, so P over Y is 4. That means N is going to be 5 times 4, which is just going to be 20. The account earns 6.8% interest, and that is compounded quarterly. So C over Y is going to be 4, and the reason this will be 4 is because it is compounded quarterly. So I'm just writing these in because the numbers are the same in this problem, but they're coming from different places, and they don't always have to be the same value. There are problems where they are different, particularly in Chapter 2. How much money will he have to buy his car when he's 21? So there is no initial payment. We want to figure out how much money there will be when he's 21 years old. So we're going to take all of these values that I have written down on the screen here. We're going to put them in the TVM solver, and then we're going to do alpha and enter in order to solve and find how much money they'll have in the future at that point in time. So in the background, I'm going to put these values into my calculator right now. And my future value is $14,150, and after rounding, 77 cents. So what does this tell us? So in the problem, we want to know how much money will he have to buy his car. Oops. So he will have $14,150.77 to buy the car. I'm going to put that as an A. The B asked how much interest will he have earned. So to figure out how much interest has been earned, we need to figure out how much he paid, and then from that, we can find the difference between what was paid and what the total value was in the account. So, how much did he pay for this investment? Well, $600 every 3 months. And how many of those payments were made? We made 20 of them. So $600 per month times 20 total payments. This is $12,000. So that's the amount of money that Fraser, goodness, that Fraser paid towards the investment over those 5 years. So what is the interest? Well, in the end, Fraser had $14,150.77. He invested $12,000. So any additional money past the $12,000 has to be interest that was earned. In this case, I believe this ends up being $2,150.77 of interest. So $14,150.77 would be the amount of money. Apologies, this seems to get reset on my stream every time I accidentally move that around. I think that should be good. Okay, so $14,150.77 is the amount of total money that was accumulated after a 5-year period. How much interest was there? Well, we take the total money, and from that, we subtract the amount of money that he paid towards the investment. So that gives us interest of $2,150.77. Okay, so that's number 5. I'm going to do one more example. And let's look at 1.5 on page 55. Question number 6. Let's see if I can do this without tilting the iPad. Great. Okay. Before I even read the question, let me put my grid in. All right. Question number 6. So we have Zoe deposited the same amount of money at the end of each month. So right away, before I go any further, P over Y has to be 12. So this is because they were monthly deposits. So the same amount of money was deposited every month. For 2 years, so N will be 2 times 12. So there were a total of 24 deposits over a 2-year period. In a savings account that earned 6% interest, compounded monthly. So C over Y is the same because this is compounded monthly. But again, these values don't have to be the same. They are the same for these textbook questions, but they don't have to be the same, and for some questions they are not. She ended up with $5,000. So $5,000 is the amount of money that was accumulated at the end. How much did Zoe deposit each month? So we want to figure out what Zoe's monthly deposits were. So there is not one lump sum. There were multiple deposits. We want to find out what the monthly payments are going to be. So we're going to take those values that are in my table, and I'm going to put them into my TVM solver. 6, 0, 12. All right. So for my payments, I got negative 196.60. So the question asked, how much did Zoe deposit each month? So we have Zoe deposits $196.60 per month. That's a 6, I promise. I don't think I made it any better. Oh well. Okay, so that's another question that shows an example of doing the monthly payments. So key difference between the monthly payments and the PV, just to kind of summarize, PV is you make a single investment at the start. We use the PMT if there are regular, repeated investments. So these investments are made over time, again and again, perhaps every month, perhaps every year, but they're made repeatedly and not just one time. If we were doing this with a formula, we would have to do a separate calculation for each one of those regular payments. So if I just look briefly back at this problem, 2 times 12 was equal to 24. So if I wanted to solve this question using a TVM solver, I would need to use 24 different compound interest formulas. If I wanted to solve question number 5 with a formula, I would need to use 20 different compound interest formulas. So that is a large reason why we use the TVM solver and use technology in order to solve these. The other one would be if you, work at a bank or in financial investments. My mother worked at a bank for a fairly large period of time. I guarantee you, you are not going to walk into a teller or walk into a financial consultant, ask it about a mortgage, and they're not going to get at a piece of paper, and try and work out the compound interest formula to tell you how much you can afford to invest. They're going to solve it using technology the same way we just solved these using technology. Their technology may be slightly different, it may look different, but it will be the same thing. You're going to put values into a online calculator and tell it to calculate, and it will give you back a result. And I've seen them. They really work no differently than the TVM solver. They're just more user friendly.